What we're going to work on in this video is learning how to graph hyperbolas. Now, the difference between the hyperbola equation and an ellipse equation is that hyperbolas have a negative in the middle, whereas ellipses have a plus. So this is the general formula for a hyperbola centered at the origin. Now, if I was to ask you to graph something like this, we would do pattern matching. We would look at everything in this formula and say what is different here. In this case, we see that the a squared is 25. So we write a squared is equal to 25. And then we'll square root both sides and get a is equal to 5. Now, normally when you square root both sides, you add a plus or minus. But because a is going to be a distance, we only look at the positive version of the number. Now, when we look at the b squared over here, we see that it matches up with the 9. So we have b squared is equal to 9. In order to find b, we square root both sides, and we have b is equal to 3. Now what we're going to do is we're going to build a box, the same kind of box that we built when we were drawing ellipses. So this a tells me how far to the left and right should I go from the center. So I'm going to count boxes, 1, 2, 3, 4, 5, and draw a dot after the 5th box. And I'm also going to go to the left 5 boxes, 1, 2, 3, 4, 5. Now in terms of the b tells me how far up and down to go from the center. So from the origin, I'm going to move up 3 and move down 3. Now from here, I'm going to draw a rectangle. Now, if this was a plus, it would be an ellipse, and we would just draw an ellipse inside of our rectangle. But because this is a minus, this tells us that it's a hyperbola. Now, the way we draw a hyperbola is we take that same box that we drew with an ellipse, and we draw guiding lines through the diagonals. So I'm going to draw this diagonally. Right? So it goes through the diagonals of the rectangle and the center, and we do it on both sides. Okay. Now, this is what our hyperbola looks like. It touches the end of this box, and then it follows the red lines. We call them asymptotes. They never cross the red line. They just get infinitely closer and closer as they go farther out. So they're just sort of guiding lines. Same thing on this side. We will follow our asymptotes. Okay. Now the reason why we draw our hyperbola in the x directions, right, left and right, is because x is positive. Over here, the y is negative. Okay. Now, let's look at the opposite of that. In this case, the y is positive and the x is negative. So after we draw our box, because the y is positive in this case, we'll draw our hyperbola up and down, right? Because that y is positive. Over here, we drew our ellipse after we drew our box. We drew our hyperbola to the left and to the right because the x is positive. So that's one thing I can use to trick you. Now, understand that a is not the number that comes first. A is the number that is below the x. So when we are looking at this over here, the a squared is still tied with whatever is below the x. So in this case, a squared is equal to 1, and then to find out a, we square root both sides, and a is equal to 1. And then the b squared is tied with the 4. So to find out b, we square root both sides, and we get b is equal to 2. So let's be careful now. A tells me, right, the number that is below the x tells me how far to the left and right to the go. So in terms of A being 1, I should go left and right, 1. And B tells me how much up and down to go, 2. So now we're going to draw our box that goes through this cross. And then we'll draw our asymptotes that goes through the diagonals. Okay. Now, because the y came first, we'll draw our hyperbola up and down. Make sure your hyperbola goes through these 2 points on the rectangle, and make sure that your points go toward the red asymptotes, but never cross it. Okay, now, we can make this a little harder by moving the center. So the center is at h and k, and you can see that our hyperbola formula is changed a little bit in the same way that it was changed when we were graphing ellipses. So we can find the h and k by doing pattern matching. We can see that this minus h is equal to minus 2, which means h is equal to 2. And we could see that minus k is equal to positive 3. So then k is equal to minus 3. And that tells us where our center is. Our center is at 2 minus 3. Right there. Okay. Now let's figure out the a's and the b's. So again, the a is what's below the x. And the b is what's below the y. And if we square root both sides, we'll get 3 over here and 1 over here. Okay, now, the a tells me how much to the left and right to go. So from here, I'm going to move 3 boxes. And up and down, we're going to move 1 box. Okay, and then we're going to make our rectangle. Okay, and then let's draw our asymptotes that go through the diagonals. Okay. Now remember, we have to double check to see whether the hyperbola is going up and down or left and right. Now we can see that the x's come first. The x's are positive, so our hyperbola is left. Make sure I go through that point. Kind of fudged it a little bit. And right. Okay. Now, we're going to do the same thing, except we can see that since the y is positive, the y term is positive, the hyperbola is going to go up and down. Okay, so first let's find the h and k. So let's do pattern matching. We see that h, oh, there's nothing here. You can think of this as x squared minus 0. I'm sorry, x minus 0 squared. So if there's nothing here, we assume that the h or the k is going to be 0. And then over here, we have minus k is equal to minus 1. So when we multiply both sides by negative 1, we get k is equal to 1. So our center is at 0, 1. Okay. Now, let's figure out our a's and b's. Now, remember that the a is below the whatever the x is. So we have a squared is equal to 25. If we square root both sides, we get a is equal to 5. Over here, we have b squared is equal to 4. If we square root both sides, we'll get b is equal to 2. So from the center, which is right here, I want to count 5 boxes. 1, 2, 3, 4, 5. All right, that's the edge of my rectangle. Then I want to count another 5 in the left direction. 1, 2, 3, 4, 5. And then I want to count 2 up for my B and 2 down for my B. And then I want to draw my little rectangle. Okay. Then from my rectangle, I'll draw my asymptotes through the diagonals. Oh, I got a little Jimmy hands there. Let's try that again. And then let's double check. The y term is positive, the x term is negative. So we're going to draw our hyperbola. It's going to go through this point. It's going to follow the red lines, and it's going to go up and down. Okay. Well, thank you for watching this video.